Welcome to Educator.com. Today we're going to be discussing ratios and proportions. We're going to begin with some definitions. A ratio is a comparison of two numbers by division. And there's a couple of ways that we can write this. So if we want to talk about the ratio of x to y, it can be written as x and then a colon y, or x over y with a fraction bar between them. Okay, what a proportion is an equation stating that two ratios are equal. For example, y over 3 equals z over 5 is a proportion. It's stating that these two ratios are equal. 1/4 equals 3/12 is also a proportion. So here we have one involving a variable, the other is just numerical terms. Cross products are frequently used in order to solve proportions. What a cross product is that if A over B equals C over D, which is a proportion, then we can say that AD equals BC. And we arrive at cross products through what's called cross multiplication. So looking at the proportion, A over B equals C over D. Cross multiplying means that you multiply the denominator of one of the terms times the numerator of the other. And you do the same thing on the other side. The denominator of this right term times the numerator of the left term. And that will give A times D equals B over C. And this is a quick and easy way to solve many equations involving proportions. Illustrating this with an example. If I am being asked to solve for y and I have y over 4 equals 2 over 5, I can cross multiply. That's going to give 5y equals 8. So in order to solve the cross product, in order to solve a proportion, one way is to find the cross products. And then, as usual, isolate the variable for which you are solving. So this is asking me to solve for y, and I have 5y equals 8. So we're going to use the multiplication or division principle and divide both sides by 5. I now have the y isolated on the left, and the answer would be y equals 8/5. This is a simple example of using cross products in order to solve a proportion. A rate is a ratio of two quantities that have different units of measure. Proportions can also be used to solve rate problems. So we talk about rates in everyday life. Speed is a ratio, because what we'll say is that a car is going 50 miles per hour. So it goes 50 miles in 1 hour. So if I look at this, my top unit of measure is miles, and my unit of measure in the denominator is hours. So since these have two different units of measure, this is a rate. This ratio is actually called a rate. And it can be for other things as well. Maybe jeans are on sale and they're 2 pairs for $70. I could say that the sale is 2 pairs of jeans for $70. And the same way we handle other proportions and by using cross products, we can also apply that to rates. So to really understand ratios and proportions, you first have to make sure you know when two ratios constitute a proportion. Looking at this example, The question is asking if the ratios 8 to 13 and 32 over 52 form a proportion. So in a proportion, you're saying that two ratios are equal. 8 over 13 equals 32 over 52. That you're saying that this equation is true. That's what you're saying. So is this equation true? Let's use cross products to figure this out. The cross product on the left, I'm going to end up with 8 times 52. And then on the right, multiplying 13 times 32, I'm going to end up with this. 8 times 52 equals 13 times 32. And I'm going to multiply it out to see if this holds up. And 8 times 52 is 416. And the right side actually comes out to 416 as well. So since these cross products are equal, we can say that this is a proportion. But there's a second way to handle this. So in this example, we found the cross product, and those were equal. The cross products were equal, so it is a proportion. Another way to look at it is to look at the relationship between the numerators and denominators of the two sides of the equation. Think about how 8 is related to 32. Actually, 8 times 4 is 32. If the relationship between the two denominators is the same as the relationship between the two numerators, then I can say that this is a proportion. So 8 times 4 is 32, and if 4 times 13 is 52, then this is a proportion. And that does turn out to be true, so we know it's a proportion. And this is a little bit easier than having to multiply times 52 and things and large numbers. So it's sometimes easier to just look at the relationships between the two numbers instead of finding the cross products. This example is, again, a proportion, and it's asking us to solve. This has a variable, but we're still going to approach it the same way that we would any other proportion, and that's by finding the cross products. If I multiply this out, I'm going to end up with 15x equals 13 times 32. So 15x equals 416. Once I've found the cross products, I go on and just handle this as a regular equation where I isolate the variable. Here, since I have 15 times x, I'm going to apply the multiplication principle and actually multiply by 1 over 15 or divide by 15. Same thing. Always doing the same operation on both sides so that the equation holds up. This gives me x equals 416 over 15. This can be further simplified, but again, right now I'm focusing on how we solve for x. And that's through finding cross products and then isolating the x, isolating the variable. So x equals 416 over 15. Next example is sentences. So it's going to require that extra step of translating from the sentence into an equation and then going from there. Jack drives 372 miles in 7 hours. At this rate, how long would it take him to drive 531 miles? It mentions rate, and we know this is a rate because it's a ratio involving two different units. Jack drives, so Jack, the rate at which he's driving, the rate of his driving is 372 miles in 7 hours. So I know that that's how fast he's going, the rate he's going at, 372 miles in 7 hours, and miles and hours are different units, so it is a rate. And what this is asking me is, at this same rate, if you kept driving at that rate, how long would it take him to drive 531 miles? With rate problems, you're frequently going to set up a proportion. So what I know is 372 miles is how far he can drive in 7 hours. And what it's asking me is how long it would take him to drive 531 miles. So I want to set up the right side of the equation so that I have the same units in the numerator as I do on the left side of the proportion. Miles and hours. Well, what it gives me is 531 miles for the second part. And what it's asking me is how long it would take. So the question really wants to know, how long is it going to take for him to drive 531 miles? So X is going to be the number of hours to drive 531 miles going at his current speed. Find the cross products, which will give you 372 X equals 531 times 7. Therefore, we have 372X equals 3717. Let's multiply that out for you. And then to isolate the X, divide both sides by 372. Finally, you end up with an answer. X equals 3717 divided by 372 comes out to 9.99999. But we can go ahead and round that off and say that X equals 10 hours. It doesn't specify here, but in your problems it might tell you to the nearest hour or tell you how to round off. This example is also a proportion, but it's a little bit more complicated. You still can multiply and find the cross products even though the terms are more complicated. This time we have 12 over y minus 3 equals 40 over y plus 4. Same as always, cross multiply. 12 times y plus 4 equals 40 times y minus 3. Now we have just the same kind of equation that we've worked with before. So first I'm going to find the cross products. Then I approach it just as I did previously, meaning I remove the parentheses, remove the grouping symbols. And then isolate the variable. And I'll have my solution. Using the distributive property, 12 times y plus 4 is the same as 12y plus 48. 12 times y plus 12 times 4 equals 40 times y minus 40 times 3, which is 120. I'm going to move all the y's to the left and all the numerical terms to the right. So subtract the left, subtract both sides, times minus 40y. That gives me 12y plus 48 minus 40y equals negative 120. And 12y minus 40y is minus 28 plus 48 equals negative 120. Going up to here, moving the 48 over to the right side by subtracting both sides by 48 equals minus 120 minus 48. Y. Okay. Negative 28y equals minus 168. One last step and we'll have this solved. Divide both sides by minus 28. And we have y equals 168 over 28, and you calculate that out, and it's y equals 6. So this took a lot of steps, but same basic principles. You start out with your proportion, cross multiply, remove the parentheses, then move all the y's to the left, the terms containing y to the left, the numerical terms to the right, isolate the variable by using addition, subtraction, division, multiplication, all the usual, and then simplify, and it comes out to y equals 6. That concludes this lesson on ratios and proportions. Thanks for watching educator.com.